My name is Cesar Escalante. I am a Design Technology Manager for HOK and the coordinator for the group, along with amazing volunteers that enable us to host this event. And we have two exciting presentations today. We have Colin McCrone from Autodesk. He's going to present the topic Advanced Data Management in Dynamo. And on the line we have Edwin Guerra, connected directly from Vancouver, with the topic Dynamo from the BIM consultant's perspective. Welcome, Edwin. I know you're in the line, but thank you for your time and sharing your knowledge about the uses of Dynamo. A few announcements. We are starting this month with educational module. So what that means is that you have the ability to bring your laptop and take with you some data sets, and we'll do a very short exercise on Dynamo. We understand that Dynamo is a hands-on tool, so the best way of learning it is by doing it. So we want to give everyone an opportunity to improve our knowledge on Dynamo. We have a resource here, great, with Colin, and today is the first time we do that, so thank you. Another thing, if you're attending in person, please register on Eventbrite. The dude downstairs is not going to let you come in if you are not registered, so please register. The alternate is they're going to try to call me, but I'm here at the room, so they can't get in touch with me. So register on Eventbrite if you are coming in here. The closeout is it's 11 in the morning on the date of the event. So at that time, there's no more registration allowed. Thank you for our sponsor, ID8. They are very generous with the food and the beverages. The next meeting is April 13. We're going to host Anthony Buckley-Thorpe from Flux. We're very excited to know what they have to share about the interfacing Flux with Dynamo. And as always, we're always looking for speakers. If you have doing work on Dynamo on your end and you want to present it, feel free to reach out. You have the choice of doing the short educational module or do a full feature presentation on a larger topic. We're booked till August, so September, October, it's still available. So. All right, let's get started with Colin McCrone and his topic, Advanced Data Management in Dynamo. I'll make you the presenter.
Okay.
You've got the ball.
Okay. My name is Colin McCrone. I work at Autodesk, and I work as part of the Dynamo team. I'm the computational design evangelist there. So I try to, help users like you get set up and started. There was interest expressed in some previous meetings on just having some way to just sort of go through the nuts and bolts sometimes, and have to use the first part of the meeting as a way to just look at one particular topic, so that we can help sort of understand that, and have it just a chunk, and then move, take that back. So the goal is to help everybody sort of understand how to just deal with lists of stuff, and also some tricks, honestly. Many of you I'm sure are familiar with List.Map and nodes like that. I can certainly talk about that, but I also want to give you some options around using something like that, because it's not very popular. So I'll talk about a couple of the things. Please feel free to interrupt with questions. We're certainly a small enough group that we can, if I'm going too fast or I said something that you don't know what that word is or something like that, please just stop me. We have enough time, and I'll talk here for about a half an hour. So it's a totally boring topic on its own, like Bueller, right? So I'll try to show good stuff. But before, I wanted to say, just since the last month that we met, there are just a couple things that came out. One is, so with Dynamo, if you have a graph or a script, a Dynamo script that it has no file dependencies for now. So just like does some geometry stuff or looks at some iterations, design options, things like that. I'm sure you're aware you can already publish it to a cloud and share it with a URL. It's an option in 091. So if you look at the most recent daily build. Was there a question? Okay. All right. So you can already publish that, and you have something called a customizer, which you can share. And now you can actually use that and put that right into a format model too, which is new functionality that just came out. And then another thing I really want to show is that since in the last month or so, the number of Dynamo user groups in the world has exploded from 4 to 15. And so I don't know if this is kind of which is pretty cool, right? And these are groups that actually have cities in and of themselves, and these are they. I don't know if you can pick out all the cities. I'm the one who made this graphic, so I know what they are. But they are Boston, Atlanta, Chicago, Copenhagen, Dublin, Netherlands, San Francisco, Seattle, Southern UK, Singapore, Shanghai, Washington, LA, Tokyo, and Northern UK. So that's pretty cool that happened like in the last 4 weeks. Anyway, so there will be I just finished a blog post on that'll come out tomorrow, with some other things like that. So, yes, go ahead.
I have to reconnect to the WebEx.
Sure.
I don't think they're getting audio. Sorry, there's.
We may not have
We
network.
don't have.
I think, yeah. There's no Wi-Fi today, I think.
We got a network access attack this week, so sorry about that.
Welcome to WebEx. Enter your access code or meeting number followed by pound.
Do I have to reconnect too?
No.
No.
Enter your attendee ID number followed by pound.
Has anybody not gotten the thumb drive?
Hello, people on the call. Can you hear me? Can you let me know on the chat panel? All right. Sorry about that. Go ahead.
Okay, so as far as data management, there are two concepts I want to describe, and the first is a data type. So a data type this is an example if you use the object.type node in Dynamo on different things that you find in Dynamo. So in the first, if you take something like the origin point, and if you look at object.type, it's going to tell you Autodesk.designscript.geometry.point. Mostly you want to pay attention to the last word. It's a point. Similarly, if you did, just a bunch of text, the computer science term for that is string, and so that's how the term that comes up in Dynamo often. So that's the type of thing is a string. Similarly, you have a couple different types of values for numbers. These are the special values that you really sort of need to know. Everything else sounds like what it is. But if you see this in Dynamo, something like an integer, or sometimes it's written int.32, that just means a whole number. It could be negative, 0, or positive. There's a double value. If you use Dynamo for a long time, there used to be something called a double slider, which really confused people. It's not two sliders. It's actually a slider that has decimal values in it. So it now just says number. But you may see the word double come up in Dynamo too, and that just means it's a number that has more precision than an integer. String is text. A Boolean or bool is like a true-false value, or 1, 0, kind of on-off. And sometimes you'll see this stack value thing. It's kind of weird. That's what a function is. don't worry about it. But the other one that's really important that I want to point out is this var, which really just means something generic. Like var just means, it's just something. It's kind of a placeholder. It's just a piece of data. But these are the ones that are sort of common. And then you also have like this idea, like, you know, you can have these really long data types that are really super specific. So like in this case, you would call this a dog, right? But like more precisely, you say, well, you could use this Latin name and say it's a Canis lupus, but this is what Dynamo would tell you, would be super specific and tell you exactly what it is. So just know that, like, you know, you have these objects, this type of thing, and Dynamo often distinguishes between what they are. So first thing is just data types. And the reason that that's important in Dynamo is because some things make sense and other things don't. In the first example here on the left, I'm adding the double value 3.000 to an integer 10, and that makes sense. 3 and 10 is 13, but 3 plus Wednesday does not make sense. So that's when you'll get a value something like null. So Dynamo really pays attention to the data type. Just as level setting, you'll see that a lot, and we're about to see that in a minute. But the thing to hang on to is that var is just like anything.
So was var the day of the week Wednesday?
No, actually Wednesday in this case, the data type is day of week. In fact, almost all nodes in Dynamo, it's a good question. Almost all nodes in Dynamo have this, the return, like the output port is the name of the data type. So if you go back to here, like in the first one there, it says point.origin and it's capital P point. That's actually the data type, the shorthand version of it. Similarly for point.x, it's a double value. And in this case, you'll see this. It's like a racetrack. You'll also see this thing show up in the plus node is a good example. Sometimes you'll see this var bracket bracket dot dot bracket bracket. I had this really great question from Paul Aubin. He emailed me like a few weeks ago, and it was this one-liner email, and it said, "What does var bracket bracket dot dot bracket bracket mean?" I hope it's a simple answer, which is like hysterical. But yeah, I hope so. So first of all, you know what the var means. The var is just a data type. It just means something. It's just kind of a placeholder. The bracket bracket thing we'll get to next. But I just want to point out that these nodes, the plus sign, like a lot of stuff can come out of a plus sign. So you can actually have, you know, a double or an integer go in. You can also have text go in, and you can concatenate strings, like stick two strings together to make a longer word, for example. So any sort of thing can come out, which is why you see this just kind of like, we don't know. All right. So the next part is, so we know what just the data type is, and then we also need to know about the structures. And so this is kind of how Dynamo talks about structure, is that you'll see, like if you have a single item, you can take just sort of, like on the left, it's just a single thing. So in this case, it's PES. It's just one thing. There's always just one. If you have any more structure to the data, say you have a group of them, like in like a packet, and it's like, and this is like a one-dimensional thing. So like in order to find any particular PES in that packet, you only need one piece of information, like how far it is from the left or something like that. There's only one coordinate, sort of like your address on a street. So it's a list. So you have this bracket bracket in Dynamo. So you'll see that when you hover over input or output ports. Then you have more complex stuff. So you have like a two-dimensional array, which is a bracket 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 bracket. But that just means that now you need two pieces of information to find any one piece of PES. You need to know which packet and then how far from the left side or something like that. And then there's this thing in Dynamo, which is an arbitrary structure. Like it could be a mess, it could be well organized. It's whatever you want. This is like when you get that dot dot. So nodes in Dynamo, that's the syntax, and then the nodes in Dynamo pay attention to that, and then they replicate, and we'll talk about that next. They replicate based on what they're expecting. So a node will actually tell you. It's kind of like sort of a more hidden feature than it should be. The node will tell you on the input port when you hover over it what it's looking for, and based on what it's looking for, it'll do something else. Okay, so that's the data type and then the structure. Any questions before we get into Dynamo? Okay. So what I'm going to do is anybody running just Dynamo standalone? Or is anybody running on top of Revit? It's a little easier if I can sort of use Revit to draw a few points and stuff, so I might do that here. Okay, actually I'm going to do this on top of family, excuse me. Okay, so I just open up just a mass file, and what I'm going to do is just make some reference points so I can reference them and sort of move them around and group them. And I'll just show a couple different examples of what I mean by this kind of thing. So the first thing I'm going to do is I'm going to look at a node called circle, and just by center point radius. All right. So if I zoom in on this, if I hover over this, it's kind of hard to tell. But the first thing says point. It just says point, capital P. So if I gave this something like a day of a week or Wednesday, it wouldn't work. I'd get a null value. It's looking for something that's a point to be the origin. And then this guy, it's looking for a double value, a radius. There's no bracket thing here at all. It's just a single thing. So it's looking for a single point, and then there's a single number that's a radius. So we can give it a few points here. So if I'm going to just sort of create some points. Here are some reference points. So what I'll do in Dynamo to get those is I'm going to select them. So I'm going to say select model elements. Just waiting for a selection here, so I'm going to do this. I'll just get those. So I just have just a bunch of points. And then if I look at this guy here, I can see that I can already tell that I have a list of things, and they're giving me reference points, so it's an element. What I want to do is just get the geometry from this. Element dot geometry. So this is going to give me the points from that. So if I hover over this and pin this, you can see I have this sort of messy structure. I'll get back to the circles in just a second. I'm just going to flatten this list because all I really wanted was a list of points to show what happens. So pretend like this is our input here. All I did was select a bunch of model basically reference points. I got the point from them, and then I got rid of that structure that we didn't need. So here's the input. So now I have a bunch of different points. But the circle dot by center point radius is looking for a single point, and since I'm going to give it a bunch of points, I'm going to get a bunch of circles. In fact, all my circles are like really small because this is in millimeters. So what I'm going to do is I'm going to give it a different radius here too. So I'm gonna just double click, and I'll give this a big radius of, say, like 50 millimeters. Man, I am not used to thinking in metric. There we go, a little bit bigger. Make them super big. Okay, so here are my circles. So what happened is that this guy, this is a list of points, and the reason I have a list of circles that came out is because this node is only expecting one circle. So since I gave it seven points right there, this node basically acts 7 times until it stops. And I can actually introduce some more complexity in this data too. So I could say like list.chop. One of the things that list.chop does is that it divides this list up into lengths of things. So like here I have now a list of lists of points right here, right? But since this circle dot by center point radius is still just looking for a single point, it's still going to work because the first time it finds a single point is buried in the data structure. So you know that like Dynamo can be super sensitive to the data structure based on how it works, but it's also based on the node. And the reason that this worked as well as it did is because it was expecting just a single point. It doesn't matter what I threw at it, it will replicate the same number of times so I get the same data structure out as I went in. Was that confusing?
Yes.
Okay. All right. So let's see if I could do it another way. So I still have the same number of circles. You can see that the input list of points here matches the input list and structure of the circles that come out. But the same would have been true if I had just taken the first one. So I'll say first item from this guy. So this is going to be just a single point right here. And I can just pin this guy. All right. So in this case, now I have just, I lost my, there we go. So I have a single point and a single circle. By the way, we're super redoing these like preview bubbles. They're a little weird. Anyway, so now what I have is it expected a single point and a single radius. So that's what I gave it. I gave it a single point, 1 point, and then 1 radius, and I get 1 result. If I gave it any structure of more points, I'll still get the same, like the data structure matches the input structure because it's just looking for a single thing. I think it'll be a little clearer if I show you another example too. So instead of making a circle, I'm going to make,
So
go ahead.
It'll take, when you give it multiple points within a list.
Yep.
It took the list and ran the points, right?
Yep.
Okay.
But every time it found a new point, it gave me a completely new circle. Like if I gave it 2 different points, I'm going to have 2 different circles. It doesn't matter where the points are or what they look like, it'll just give me a circle per every point because it only wants 1. So, but this is not the only type of thing. Like so, this is like the easy example. It only wants 1 thing. Another thing we could do is say like, if we want to make a polyline. So this is like a jagged line through a bunch of points. Yep.
Sorry. So if you give a list for the radius as well, is it going to assign the first item of the radius list to the first item of the point list?
Yes, it will. I don't want to confuse the discussion quite yet to get there yet, but yes, it would. It would. So first, I just want to talk about the input here. So in this guy, if I hover over the input here, if you can kind of tell, now it says point bracket bracket. So it's actually looking for a list of points because you can't actually make a line through a single point. You have to have at least 2. And in this case, I could give it 100 and it would make a jagged line through 100 points. So that means that this node is looking through your data until it finds a list of points. Okay?
Whereas the previous one, it just was looking for points.
It's just looking for a single point. That's right.
Okay.
So, okay, what happens if I take the first item, right here, this is a single point, and send it to polycurve.byPoints? It's a null value. This is just like 3 plus Wednesday because this is looking for a list of points, and that's not what I gave it. It can't find one, right? So this is giving me a null value. In this case, we go back here. So I have this flat list of points, and I have 7 points altogether. How many polylines or polycurves should I expect? 1. Right. So it's going to be 1. It's going to be kind of crazy and long, but it's exactly 1 because there's only 1 list of points, right? If I go to this guy, list.chop, kind of the same data, except that it's structured differently. So how many polycurves will be here? 3. Yeah, trick question. Because what happened was it found a list of points. See this? So it found 1, 2, 3. This one doesn't have enough points in it. So what the result is 1, 2, 3, and then the last one's a null. So I can make that data more complicated too, but since what this wants to eat, what it wants is a list, it won't stop until it finds a list, right? Okay. So I can make it more complicated or less complicated, doesn't really matter. If I chop this by a different number, if I chop it into 3, so I'll have a group of 3 and a 3 and then 1, then I'll have basically 2 results because it just found 2 lists in this case. Okay. So that's the secret. That little like that square bracket is like full of information. Okay. Questions there so far? I'll keep going. Yep.
You can convert a single item into a list too, right?
Yes, you can convert a single item into a list. One of the ways you can do that is by doing like create list. So you can say if I right click and say list.create, I could take this item and actually turn it into a list containing 1 point. However, it still wouldn't meet the criteria, right, because it wouldn't have enough. But yes, you absolutely can. Okay, but it gets more complicated still. So we could also do something like this. I'm going to make a new, what was that? Yeah.
What happens if you feed the polycurve node with the same point twice?
If I feed the same node, what was that?
If you feed the polycurve node with the same point twice, like if you're giving 2 points but they are the same.
It will also fail. Right. It would also, but for a different reason. It's not for a structural reason. But the question was, if you have 2 points that are next to each other, the same point, what will happen? You could have a list containing 2 points, and if they're the 2 points that are the same point, the polycurve will still fail, but for a different reason. It's not because of the structure of your data. It's because it's a logic error in that case. But actually, it won't just fail. It'll give you a null value, which is actually useful information. Like null is actually, it's a good piece of information. I mean, you could even, we'll talk about this at the very end. We'll talk about like list.filter by Boolean mask. We'll show how you can actually filter those things out. If you wanted, like that could be actually good information. All right, so here's another case where we might want to sort of to do something else. I'm going to open up one more a file that I gave you earlier, and this is going to be I'll come back to this later, but cities by Boolean mask start. So just drag that there, and there are 2 lists in here, and actually there's a list of cities and a list of countries, and they correspond where the countries are. One of the things I want to do is I'm going to make a list of these 2 things. So I'm going to say list.create. So I'm going to take this list in and this list, and my result is going to be a nested list. So here I go. I have a list of cities stacked with a list of countries. So I'm going to show you a different node in Dynamo that acts yet again. So we talked about a node that replicates on one thing and then a list of things. And here's a node that wants a list of lists. So this would be list.transpose. So if you hover over this, what this will do is, this is actually looking for, list.transpose is looking for a 2-dimensional piece of data. In this case, if I pass this in, what it will do is, when the first time it finds a list of lists, then it will basically operate. So this flips the data. Like list.transpose takes your data and like kind of like mirrors it like this, reorders the columns and the rows. So the first thing in the first list gets matched to the first thing in the next list. There's second thing, third thing. So you can kind of see how this makes sense. So you can San Francisco, USA, London, England, Shanghai, China type thing. We're sort of like matching items in the list. But this is an example of something that is looking for something that's more complex. Now in this case, this has a var bracket bracket dot dot bracket bracket. I know, because of the way that list transpose works, that it's looking for something that has working on a two dimensions. But if I want to force this then to be able to work at a particular level in my data, that's when you're starting to get into something like List.Map, if you want to move these things around. But this by itself will always work on the top level of data. It will, even if I have 3 levels deep or something like that, it'll still only work on the first top 2 layers, because it's only looking for 2 layers, and it'll stop. And then since it can take anything as a result, if I want to move it around, then I have to use List.Map or something like that. But I want to use that. But I don't want to give, List.Map is confusing enough. Kind of want to leave that for another thing. And then there's more to show, just some practical applications here.
How can you select the items based on pattern? Like you say, like a Boolean pattern. Like you say,
Yep.
Yeah, every 5 or every 6 items like this.
I want you to save that question, and because at the very end, like we're gonna do like 5 or 10 minutes on list.filter by Boolean mask, right?
Mm-hmm.
Why don't I'll answer that question then. Okay, excellent. I want to open one more file here, and that is this guy, Dynamo D data management. So here is this. Here you go. So this is a more complex graph. There's a lot of stuff going on in here. Don't worry. If you open it up, it should just work. I should never say that out loud, but like it should work. So what this is a little Dynamo logo right here. It's a riff on it. You can scale it so you can make it bigger or smaller. You can even orient it differently. Like you can make it go at a 45-degree angle. So this is like altitude azimuth stuff, like in astronomy. I can like turn it around partly, for example. So this has 3 inputs. It's really a scale. It's an origin point. I can also move this around in space. I can say I want to move this to 30, like move it way over there. I can sort of rotate it. And this all works nice, great. I'm glad it works. But it works for 1, right? Just works for 1 Dynamo D. And what if I wanted to do something like, let's pretend I don't have to know what's happening in the rest of this graph. I don't care. But what I do want to know is what happens if I gave it now a list of origin points, not just one origin point. What would happen? Well, the way I constructed this graph, it works really well for one, but if I gave it a bunch, it may not work so well because I didn't really account for that. So you know how you make a list in Dynamo with curly braces, right? Are you familiar with this? Anybody not? Okay, just off to the side, before I do that, I'll just show you really quickly. In a code block, which you just get by double clicking, you can write a single number like 5, and then you get 5. Or I can also make a list with curly braces like this. So curly braces, and I'll say like 5 and also 20. And then this makes a list basically 5 and 20. So I'm just going to use curly braces to make a list. This guy, so this point up by coordinates, I gave one number each to each of the inputs. So, and each of these inputs is looking for a single value. In fact, you can hover over it and see double. So if I give it a list for any one of these, that'll get a list as an output. So if I change the input for y, say it's just looking for a single y value, let's give it a y value. Let's say I want it 0 and 15 and 30. What's going to happen? Well, I did get 3 points as a result, but it totally broke my definition. Because the rest of the definition really was not meant to handle that, right? It just totally messed it up. So instead, so you certainly have the option to go through the definition and change like List.Map, List.Combine, that kind of thing, to move those nodes around so that they're acting at the right level. Or you can use a trick, which is basically just using the data type and the data structure that I just showed you. And so what we're going to do is I'm going to take this whole thing, everything that, all this stuff that makes the Dynamo D. I'll just also point out that the code blocks on the lower left that aren't connected to anything, those are custom-made functions. They're being referred to. Just leave them alone. But everything but the inputs. I'm going to take this whole thing, and I'm going to right-click, and I'm going to say New Node from Selection. And I'm going to say Make Dynamo Logo. And then the category, I'm going to put it in SFDUG. Say OK. All right. All right, still messed up, right? However, we don't have to keep it messed up for long. It basically looks the same. But what we can do is if you double click on the inside of this, you look over here, here are the input nodes. And there are a couple, there's actually this special syntax you can use to specify, you can tell the custom node what to expect. So this scale number, I can say, I want that to be a double value. And it's a single double value. And this one, I want it to be a point, except I installed Dynamo, so I have to actually specify that it's an Autodesk point, as opposed to a Dynamo point. So that's a point. And then this guy, it's a single vector. So now, as long as I did that, so this is actually just expecting a single thing, not a list of things, that means that this whole custom node is now going to replicate correctly, because if I hover over this, or each one of these things, this is a point, it's a single point, it's a single value, and now for sure, I don't have to go through now and make sure that all the individual things line up right, because I just sort of wrapped it in this thing and made it do its own thing. So no matter what I do, I can actually even give it a different scale value. You know, I can make them all bigger, that kind of thing. And then that's happy. So as the last sort of just little fun here, I'll show you that. Because I did want to just briefly mention List.Combine before I hand it back over to Edwin. And you can see that this is a list of polycurves that came out in the order of they're basically organized by the logo. So I have 3 major lists of things with like 6 lines in the middle, right? Well, here I have the color values for the part of the Dynamo logo. So how do I make sure these things are colored correctly? So one thing I can do is actually this whole first color, there's 6 values. I want this whole thing to apply to just this one, this second color to this one, no matter how many I have of these. So what I'm going to do is I'm going to flip the organization of this list so that I have all like the right bar in one list, the middle bar on the other list, that kind of thing. So I'm going to use that list.transpose. And this works because, of course, well, yeah, it's a little neater if I do this, I think. So now I have this organized not by the logo, but by the color being associated. Now I want to go to something, this guy. So this is geometry. It's in the surface. I have to make this into a surface. So it's a surface by patch. So I can do that. So these are going to be almost there. This guy is individual surfaces. Cool. And then you can also color things. So there's this display by geometry color. And this guy is looking for one single piece of geometry and one single color. Okay, but now I have a problem because what I have is I have a list of geometry here, and then I have a single color. Like this single color applies to this whole list. So the way that you have to now I have an offset thing. It's kind of like your first cousin once removed type. It's just weird. It just gets odd. And what I want to do is make sure I want to force this node, even though it's looking for a single piece of geometry and a single color, I want to force it to work at that one level of the list down. And so the last thing for that is list.combine. So if I make this my function here, and then I fill geometry and then color, the geometry goes here, the color goes there, and then I can turn off the preview for this guy, and you have a bunch of Dynamo logos. So this is how you get around what I just said when you have things that are not symmetrical. Any last questions? I think I ran a little bit into Edwin's time. I really apologize. So, actually, I think I was exactly at half an hour. Okay. Good.
Let's check on our audience. We can also come back to the end if you want to discuss it
Yeah.
further. All right, Edwin, if you are on the line, go ahead and unmute yourself, and at the prompt, just accept be the presenter.
Awesome.
Excellent. The stage is
You
yours.
can see my screen, you can hear me?
Yes.
Great. Well, that was really insightful. Thank you, Colin. And I want to thank Cesar and everyone else who helps organize this group. My name is Edwin Guerra. I am a BIM consultant in Vancouver, BC with Summit BIM. It's an honor to be here sharing some of my insights with you and share the stage with so many who have been so instrumental in the development of Dynamo. I did want to give you just a brief outline of where I'm coming from. I realize that most of the presenters you've hosted before are designers. I work for Summit BIM, and we are a technology and efficiency company for the architecture, engineering, construction, owner-operator industry. And we focus a lot on collaboration and data management. Here on the screen you can see some of the people who are at our office. We're spread in Western Canada, and we do work all over Canada and increasingly now in North America. So when I say I'm a BIM consultant, I'm using BIM in a slightly different sense than it's traditionally used. We are focusing on building information management. So our primary clients are building owners in different industries: healthcare, airport authorities, energy, educational type clients. And as I don't know the state of the industry in the U.S., but here in Canada, we see that owners are increasingly interested, and they don't necessarily have the background to know exactly what is possible or how to get what they want. So we help them out, and we do that through facilitation, workflow, BIM standards development. And a big part of what we do after we do that is standard compliance. And that's where this Dynamo overlap happens. And as I said, we're trying to help them realize the value of BIM by generating structured data, right? So here on the left, a lot of what we do is we help develop through those facilitation and workflows and questionnaires and surveys what it is as an organization that they value. We translate that into things that we in the BIM world understand as BIM standards, a level of development specifications, level of information specifications, project execution plans, and more. and so that basically everyone can play in the same field, knowing what the expectations are. So part of what we do is we give people access. So here I'm just discussing 2 dimensions, somewhat arbitrarily, lumping software in there. So we've developed our own interface to basically consolidate model information, realizing that not everyone wants to have Revit. They have now a way with through this interface to access the information regardless of what model it came from, in a way that's more lightweight and that they can't damage the data, that we can deploy as many licenses as possible with no cost, so that they can interrogate the information, right? So this is a specific viewer that is very geared towards interacting with sheets and interacting with the underlying information from Revit. Similarly, there's other viewers like Solibri Model Checker that we use. These are sort of in between. They also help us audit models. But basically, these are exported from Revit. So there's certain things that we can only audit inside of Revit. And that's what I'll touch on later when I get to the examples. So there's things like the number of warnings. Basically, we have no real way of automating that extraction of information. I'm receiving a call. Can you still hear me?
Yes.
Okay, so I'm not going to take this call then. Sorry. So model review is another tool that we use. That's an add-in for Revit. It's not super user-friendly, but it lets us automate things like counting how many model lines there are, seeing what the best practices are, seeing if sheet naming looks right. And then we have Dynamo, which really gives us a very powerful tool that's custom, that we can customize in different ways to get what we want. And we've been at it since the nodes were orange, which is a while ago, and when you still had to like replace DLL files to make it actually access parameter data. So that's where we're coming from. We're really interested in doing model audits using Dynamo as one of our tools on our toolbox, and looking at information. So things like how many in-place families do we have in the model, and then also for visualization, which is a much more robust way of analyzing data, so that we're not looking at an Excel sheet, if you can think of that output. But we can do things like what I'm showing here on the right, which is color coding all the different wall types, assigning them a specific color, so that then we can very quickly do a visual check and see what things might be wrong or might be correct, and gain insights from that information. So with that being said, I can jump into Dynamo. So here, this is not necessarily a node that I'm going to go through in much detail. If you've seen Colin's presentation at the San Francisco Dynamo Users Group last October, last year, he went through something very similar, which was basically writing to Excel some data from Revit. Here, the only difference perhaps is that I'm pushing several categories at the same time. So I'm using that list.create node to not only look at one category at a time. I could increase this to start looking at additional categories. So I'm looking specifically here at loadable families. If you've spent some time in Dynamo, there's different ways that you access system families and components or loadable families, which makes a difference. But in essence, what we are checking here is compliance. We're looking at the type, parameter name of all these elements, and seeing if they have some words that we have on our blacklist. Like, we don't want to see standard, we don't want to see default, we don't want to see typical, and we want to automate that, right? We don't want to have to generate schedules, export them, and then see what's wrong. So to make the story short here, we're calculating some compliance metrics, and we're generating some Excel sheets. So if you remember, I was looking at 3 different categories. one of which was doors, casework, specialty equipment is the first one. And just because of the way that it's transposing, again, these are the items that are non-compliant. So these are types that contain standards somewhere in there. It's evident here, and it's evident over here, and we're also reporting the element IDs. But we can also calculate things, and if we wanted, we could push this information to Excel. No, so specialty equipment is compliant. Casework is 50% compliant, and the last one, doors, is 59.3% compliant. So getting that type of information is pretty valuable to us, but it's not particularly exciting to look at, or yeah, it's not visual, right? So similarly, we have ways of looking at things like in-place families, and here this is very similar too. We're looking at different categories, creating a list, extracting the family type of that, because basically on the clockwork package there is one valuable node that is family.isInPlace, which basically takes in a family. So that's the reason we go from elements, we extract the family, and then we basically have that as a way of checking. This is generating a list of Boolean values. So that's true or false of which families are in place, right? So compare this to the traditional way, which is opening up Revit and having to go down and then guessing. Usually under generic, there might be some, and then seeing patterns, right? So if you see a 1, 2, 3, that means that they're probably copying an in-place family all over, which is not best practice, which can create issues down the line because these are likely the exact same geometry. So by doing this, we have a way of similarly getting a list of how many families in each of those categories. So in Windows, there's 1 is in place, and 3 that are in place families under generic models. And this is again automated, right? Something that's very hard to check visually, that's prone to error, and we now have a way of quickly accessing that information and reporting it back. So we can take that a step further, and now that we have a list of Boolean values that was generated here for every category and every family type in there, we can then use that as a mask on the original family types that were reported from Revit, so that we're isolating essentially those which are in place. From there, then we can select all of those elements from that family type, so from that type that is in place, so we can go to the element ID level and just basically color coding it using this color node so that we can turn them red and flag them, right? So all I have to do here is connect these two, hit run, and ideally I should, whoops, something went wrong there. See? Okay, so let me just try this in a different view that I have set up. See if that helps. I have to apologize for this because I'm not sure what getting some null values. But the idea is that it's basically going to turn them red. So what we would have seen here is basically these families.
You're in manual mode. Hit it to automatic.
Oh. Exactly. Thank you for that. So let's try automatic, see if that helps. Yeah, I'm not quite sure what's going on there. Everything looks right to me. Let me just see if that makes any difference. So the idea is we can report and we can produce Excel sheets, and that's nice because we can track it over time, we can graph it and communicate it and see that things are getting resolved. But it's also nice to have a visual cue at some point that we can use to verify that things are being done correctly. Okay, so not sure what was that, but it's working now. So the idea here is now we've color-coded in red those in-place families so that there's no question about where they are located. We just turned off the floors here in this view, and we can run it again in a different model. That's the beauty of Dynamo, is that we can reuse this information. The setup is really automatic. As long as there's categories that are being used, and as long as there's in-place families, we'll be able to report them. So from there, I'm actually going to just open up a different file. To go further into this color coding. So this is something that we started seeing very early on, and I apologize that I'm just showing sample files. I'd love to show you some of the work we're doing with our clients, but obviously we can't get permission due to the nature of the work. So color coding is something that you can do inside of Revit. You can create a filter, for example, to look at the lengths of these beams. But if you were to do that, you'd have to do it manually, and you'd have to go to Visibility Graphics, and you'd have to set it up automatically on each view, which is quite a bit of work to do, because you have to manually maintain it, right? And you have to set it up for every single project. So Dynamo actually has a override color node that is very powerful and has improved over the years. And that's what I'll show you next. And the idea here is that this is more geared towards design, right? Because designers are not necessarily used to getting feedback in this way. And what we're doing here is we're again grabbing structural framing. I like to select the categories this way, and that's probably a legacy, because it used to be that you had a drop down, and I always got annoyed that whenever I opened the definition, I had to scroll down a super long drop down to get to the category that I wanted. So this way I basically can hard code it in so that as soon as I open it, it's there. So the idea is that I'm selecting that category, grabbing all the elements from that category, which in this case is all the beams, structural framing, and from there I'm getting a parameter which is the length parameter, which all of these elements will have. And I am then remapping the actual length that's reported, which is right there, so that I can get it into a range which is now going to be between 0 and 1. So the reason we do that is that the color range node basically accepts only values that are between 0 and 1. So you have to normalize your data, and that's what we're doing here, so that the shortest beams will actually get a color, and then the longest ones will have a different color. And then we're just basically passing those same elements that we were collecting initially to override them in the view. And this is what we get when we do that. And from a design standpoint, then you can start looking at patterns, right? And that's the beauty of using colors, that very quickly you can start detecting patterns, and things that might be wrong can jump at you, but also opportunities for maybe standardizing your base size so that it's easier that kind of analysis is possible. So designers can get a feedback into what they're doing and realize new opportunities. So the same way that we did this, we can very quickly do other categories, right? So we could do columns instead. And the idea is that it works very nicely for these type of problems where you have what's basically a double, a number with a decimal point, a continuous range. It works very well. So then what I wanted to do next was look at how can we deal with things that are not continuous but discrete. So for example, if we wanted to color code things by type, how would we do that? So you had a visual cue now in color of what types are loaded into a project. And what we can do then is use the same idea in this node, which again I will share all of these with Cesar so he can distribute. Is that we're collecting all, again, for a specific category. We can collect information. We can extract the type. We can extract then the type name from that type parameter. We can reduce that list. That's basically looking at all the elements that are in there. So of course I have to connect the first one to that. And so this is basically that elements list, watch node. We're then extracting the families, the type. So that's the type name basically, so that we can reduce that list eventually. We can count that, generate a new list again from 0 to 1 that has that the counted elements. And then we can basically push that, and I'm using a specific node from string nodes in this case. That's using a dictionary, so we can create essentially what would be the equivalent of a lookup table in Excel. So on one hand, I'm looking at the unique items, so that's the unique types that have been used in this project. And then on the other hand, I can look at this code block that is basically generating as many points within 0 and 1 that is the same length. So the idea is that I can then create a search basically, so that every single element that's loaded into the project is basically looking up what type name it is and then what value, what color essentially it will get. So the color range generates the color, and then we can push back the element into it. And the beauty of this is that then we can color code by a discrete type, which is in this case now doing the column. So I could maybe just turn off structural framing so that we're not confused. We're just looking at the columns now. So what different types of columns are being used? And they're all getting their own individual color. So I will extend this now and open up a different file. Let me just close some of this. And I'm not going to save it. And I'll go back to that architectural file. Looks like I crashed my Revit, sorry. So as I mentioned earlier, maybe for setting up the next example, what I did here was I was color coding loadable families again. So if we're dealing with system families, so things like walls, floors, ceilings, we have to treat those differently inside of Dynamo. So in this case, I will show you a definition that, again, I started off with the same type of definition, but now I adapted it to look at walls. So this would be a color by system family. So in this specific example, I'm going to use walls. So the idea is, again, we select the wall elements however you like. There's different ways of doing it, one being shown here. Then we can use different custom nodes. In this case, I'm using the Clockwork library, the package. And I am going to generate basically the types from those elements, what types they belong to. And in this case, I was using, like before, the type name, but I found that to be somewhat unstable. So I actually ended up using the element ID in this case. So basically, this is the ID of the element type. So, so basically, it's going to generate that list of all the types, the different types. You can see there's a, for each one of those instances, right? And basically we can count them, do the same idea of generating enough divisions between 0 and 1 as we have elements, so that we can create, again, a sort of a lookup table. So then we can look at every single instance that was used in this model for each wall and color code it, or generate a color for it, and then push the elements back. So here's the final result, which is basically now color coding every wall type with a different color, so that you can visually inspect and see things that might be odd or might make sense when you're examining a model for model compliance or for good modeling practices. Here, for example, it's evident that they've modeled the parapet separately, which would be a good practice. Again, you can estimate it separately. It'll be a different trade involved. So there's a lot of benefit to seeing things that are just might seem odd at first. So like, why is this wall a different type? Well, that's a stairwell. So that's a stairwell. Why aren't they all the same type? Are they combining the finishes too with these walls? And it's a way of, again, visually, rather than looking at a list of Excel values, seeing exactly what is going on that's wrong, or might generate a new discussion of how things might be done in the future. And as I said, the beauty is, again, this is totally extendable and to new projects, so I could open a different project, run the same definition. The setup is very simple. It's using the data that's within the model. I don't have to set it up myself. And I can assign everything a different color very, very quickly. So that kind of gives you an idea of the types of things that we look at when we're using Dynamo. And the idea, again, is we're also generating custom views at times, so we could start, instead of coloring by the element type, we could start coloring by information that's held within the wall, STC rating, fire rating. We could do walls and doors at the same time and start gaining new insights that are, again, visual. Some things are very easy to check visually when you have a 3D model, and they're not so easy to check sometimes when it's a non-graphical. So there's a balance, and it takes kind of an art to know which tool is appropriate for each use. And that's basically what we've been doing here at Summit BIM. Is finding new ways of using the information-rich models to give us new insights and new ways of seeing information. I think I ran a little short, but if you guys have any questions, I think we can open it up.
Edwin, I do have a question. This is Cesar. What do you think is the advantage of this method versus the Revit filters?
Yeah, so the Revit filters is just quite tedious because it would be manual, right? If I were to open a different file that had different naming conventions, basically I'd have to start from scratch, generating based on whatever the type name or type mark inside of this model was, right? So I'd basically have to create one filter for each color manually. And you can very quickly see that's going to be quite intensive. And as the model changes, there might be new wall types that will get added at some point, and that means that you need to manage it again and manually create a new entry for it. So to me, the filters might be nice if you know that, for example, fire rating, you only have so many options, and that there's a consistent way that the information is being input. But in this case, we're just using basically the element ID of the type. So we know how many types are loaded. We know how many types are being used in the model. For the ones that are not being used, we're not counting. And it's really automatic in the way that it generates colors. Of course, you could play and find different colors or different color gradients that might be more suitable. But the idea is that this is truly extendable to different consultants. Like if we're looking at a model generated by HOK versus Stantec versus someone else, we can use this reliably. And I see a question from online that asks if the colors remain after you close Dynamo. And the answer is yes. This node actually uses basically it's an override. It's as if you were clicking on something and saying override graphics in view by element, which normally is not good practice because it's hard to track. But you can see that if you reset it, it'll go back to normal, right? So it's basically for this view only. And it is an override that was applied to that specific element. So if I were to save, close, and reopen, basically it will be, and the color will be persistent, but only in this specific view. So yeah, and the reset process, as we said, was basically if I wanted to reset this, I can select it all, filter, that I only have the elements that I affected, and then I can right-click, override graphics by element, and reset it. And now I'm back to normal. Cesar, maybe I should ask actually, how do you normally share these Dynamo definitions? Do you do it on the website, or do you do it only with attendees?
So this is the first time we do hands-on, and we pass around a USB, but I think the plan is in our website we're going to create moving forward, when the video is posted, we're also going to make available the DIN files that belongs to that one, so you can download it. So
that's great. Yeah.
Are you planning to share some of your definitions with us?
Sure. Yeah. I'll share them with you so you can find the best way to distribute them or post them.
Great. Any other question for Edwin? And here's another one from me. Sorry. How's Dynamo being used in Canada?
Well, I think designers are using it for generating and automating, right? Complex shapes, randomizing. I think there's still a lot of opportunity for people to take it on. I think that everyone could use Dynamo, and it's very useful. You don't really have to make funky, crazy shaped buildings to get some value out of it. So again, things like automating cleanup of views and naming, those are all big opportunities that could save people quite a bit of time. So reading data from Excel and using it in your model, I know that there's people that create rooms and then they place them. So things like that I think are going to be more common, but the uptake is still, it's working its way. I think people are probably, like in the US, very hard pressed for deadlines, so they have a limit to what free time they can offer to learn new tools or learn increase their knowledge within Dynamo.
All right.
I'm seeing another question here online. So it asks, from a BIM consultant point of view, are there any problems with designers using Dynamo to create content we should be careful of? Well, I think the common problems that we see are normal, no? Which is a lack of standardization. So basically, we're interested in, when we deal with owners, to push data for things like facilities maintenance, to generate custom views. And all of those things are only possible if you have structured data, right? Which means that you're using some sort of consistent system to name materials, to name your families, to provide shared parameters that contain information. And what we see, if we were just to grab a model that's being used for construction documents, is that they look great on paper, but the data within them is not necessarily organized well so that it can support additional downstream usage. So, I mean, things like OmniClass, there's some challenges there, right? So like Revit ships with the old OmniClass file, so you actually have to override it with the correct one, table 23, and then you can use it. Challenges like in-place families, generic models that have families that may be well defined within a category. So maybe someone made a funky furniture item and they just left it as generic model. Well, when we're assigning that information so that a trade can provide specs against it, we don't want to have to go into two different categories, right? We want to go to furniture and grab everything that's required there. So there's a lot of opportunities like that for designers to generate the models that can support downstream usage, estimating, construction sequencing, and attaching data consistently.
Awesome. Any other questions?
Can you speak at all more about Dynamo's ability to work with programs like RAM or SAP? He mentioned that there's some compatibility with Excel, between Revit and Excel and Dynamo. But just because he's in the construction industry, I wonder if he's come across any other analysis softwares that they've integrated with?
I can't quite hear very well, but I hope someone can repeat.
I'll repeat that for you, Edwin. The question is if you have any experience of
specifically
interoperability between using Dynamo and SAP for structural engineering.
Yeah.
I haven't used it myself. I know that I believe there are some nodes that do some of that work. But yeah, unfortunately, I don't.
I can answer so a little bit.
I'm seeing another question online that asks, in your wall example, will the color change if you change the wall type? So, I mean, let's just run through it again.
So, Edwin,
that's a good question.
Edwin, we have a comment here from Colin regarding the previous question. I'll let him talk.
Oh, just really quickly, the Dynamo SAP package, I believe, works with steel and thin shells specifically. Interoperability with Dynamo.
All right, go ahead.
Okay, so I just reran the script to illustrate the question. So the question is, if you change the type, will the color change, right? So the answer is it won't change until you run again, right? So it's a one-time thing. So when I run it again, now it detects that it's the same color as the other type, and then it will update. So that is something important to keep in mind, is that these are scripts that you have to run again. So that's also in comparison to the filters that we were talking about, right? If you were to set up the filters, it's very manually intensive, but the idea is that it will always be live, reflecting the condition of the model. Whereas this definition is something that we have to run every time there's an update, which for us isn't a problem because we receive these at milestone submissions or established schedules.
Great. Any other question?
After you set up the coding for different model types, have you tried to transfer the geometry to other software, but also keep the color coding?
Yeah.
Like if you transfer the geometry to the 3D Max or Rhino, and the object still keep all the color coding.
So, correct me if I didn't catch it correctly, but I think that the question was if we utilize geometry from other sources, like from Rhino, would we still be able to apply the same overrides? Is that correct?
No, if you just
Vice versa.
export the geometry from
Vice versa.
Oh, if we export the data to another type of format, say IFC of Rhino or SketchUp, would the geometry retain the color coding?
My impression is that when you do those type of exports, it's looking at the materials, and it's not necessarily looking at the overrides. So I know that this has been asked with regards to things like BIM 360, because it's essentially creating a cool view that is relaying some valuable information. But at present, as far as I'm aware, it's not possible to export these colors outside. There's probably a way, and Colin might be able to comment, that you could individually grab each geometry and then set it up so that you could assign a color perhaps when you do the export, like a SAT file or something.
Yeah, I can say just quickly there that the override color and view is then a property of the view, not of the element itself. So if you wanted to export that information, you have to come up with some way for assigning a particular material or putting some tag.
Yeah, and I'm sure that future presenters, someone's commenting online, you could use Flux to transfer the data. So that might be a good question, yeah, to ask other people.
That was Jeremy. He's one of our volunteers. He should be here, but he's online.
Yeah.
All right, there's another question from Adam Simmons. You want to read it?
Sure, yeah. It says, do you have any standards for how to set up your definitions? So here I'm assuming that's a Dynamo definition. I actually don't. I tried to use the cleanup node and then reorganize at the very end, but I think the only thing that I try to observe that I saw Colin use was kind of indicate whenever you're using an external package, just create a little note or something that tells you where that is, because if you share this with other people who don't have that package, it's very hard for them to know where it's coming from. And then the second part of that question is common organization, naming standards, etc., tips for being well organized. Yeah, so we help develop those.
이제 살만하신다고 굳이 이제 바보라고 막 그러는 거 보니까 이제 말대꾸하고 말대꾸하고 살만한가 보지 이제.
배 아파. 봐.
Someone might have to mute themselves. Yeah, thanks. Yeah, so the second question, part of the question was regarding naming standards, and basically those, we try to give through the project execution plan consultants flexibility to define what naming standards they're using, and then we'll check against that. Because we don't want to be too prescriptive and too restrictive on how people work. To us, as long as the naming of the family and the type is clear, so that someone can read it and know pretty quickly what they're talking about, that is good enough for us. And then the data is what we focus on. So things like the level of the information matrix for every category that will say what shared parameters or what built-in parameters we expect to be populated. Those are the things that we really use the most, because then we can use that data for color coding if we want to, and for a variety of other uses, creating custom views. Because that's one thing that we do, is we generate custom views for the owner, which are separate and different from those that are being used to build a model. So they don't really necessarily need to have dimensions, they just need to show things of interest for someone who's operating a building, no? So things like where the card readers are, where the security cameras are. We can highlight those in a view and generate that and give it to an owner, so that they actually can look at that view rather than looking at the black and white issued for construction sets and stuff like that.
Great. Any other question? People on the line? If you have any question, just write it down.
What are some of the most important or helpful packages you use in Dynamo? Well, I really like Bakery. Bakery will install Clockwork, Archilab, Grimshaw, and I'm sorry if I'm missing a few. Yeah, Launchbox. So it'll install pretty much everything that you would end up using. So when I share these files, you'll see that a lot of the custom nodes are Spring nodes or Clockwork, and some might be from Bakery. So there, I think if you install Bakery, you're pretty much well standing for moving forward. And in some ways, Dynamo is like a gateway drug to the API, or at least that's how I feel, because when you start seeing these custom nodes and how valuable they are, the amazing things that they do, you start wanting to get into it and hitting edit custom node and then looking at what they're doing, right? And it looks manageable. It doesn't look impossible, but it will take me some time, I'm sure, to get into it.
Awesome. I don't think there are more questions from the audience, and neither from the chat. So I want to really appreciate your time, Edwin, for sharing your knowledge on Dynamo, the work you're doing. You're welcome to come to the Bay Area sometime and have you as a guest anytime you want. If we can give Edwin an applause.
Yeah, thank you so much for the invitation, and and thanks again for the invitation to the Bay Area. I'd love to visit. San Francisco is a great city. Thank you very much.
Fantastic. So hang on, because we're going to wrap the meeting with the last portion of it, which is we're also going to start featuring a node per meeting. And Colin is going to facilitate the explanation of what nodes so that we understand how it works, how we can utilize, and we can disclose it, the full functionality. Colin, I'm going to make you the presenter. And this meeting will host the filter by Boolean mask, I believe.
Okay, so this is kind of like Sesame Street. Like today's meeting is brought to you by the node list.filter by bool mask. So the idea is that every meeting we'll just do one really useful node, because there's I don't know, 10 to 20 nodes that are just pretty useful. This one, list.filter by bool mask, was the first candidate, and this guy takes a list, any arbitrary data structure of anything, and some sort of mask that meets that, and a mask is really just a corresponding list of true and false, and then sorts it. Everything that's in, something corresponds to a true value, you keep it, and if it doesn't, you put it in the out category. So back to this example with the cities. So here we have 7 cities, and here we have their corresponding countries. So we can do something simple, like we can just sort which ones are in the United States. And the way you want to do that is, this is the list we want to act on. This is what we want to filter, basically. And we need to find some sort of logic to turn something else into a series of true falses. And so one way to do that would be to ask if the country name equals USA. So we can do equals, 2 equal signs for the equals to operator, by the way. In case you weren't familiar with the 2 equal signs, if you use a single equal sign in Dynamo, then you're assigning something. Like if I say x equals 7, that means x is 7. But if I say x equals 7, that says does x equal 7? And the answer is always true or false. So they're 2 completely different things. So if you're asking a question, it's 2 equal signs. So one thing is you can ask is the country equal to USA? Is that true? And you'll get a list of true and falses. So if I say that's the mask, then the results are in and out, and I'm going to use 2 different watch nodes. In San Francisco, Atlanta, Boston, out London, Shanghai, Manchester, and Tokyo. So cool. So that's one example of what you would use that. And just sort of quickly, one other example, more geometry focused. I'm just going to open up the sample in the core library. That's the attractor point. So if you look at this guy, and we change the manual type to automatic, so it's running continuously. So one thing we could do is we could just visualize, for example, only this guy just works, of course, by if you've played around with this, you can move this point around, and then basically you have this effect of the size of the cylinders based on the location of that point. One thing we could do is, here are the cylinders here, but we can actually visualize them based on, for example, I only want to see the cylinders that are within a distance of 30 away from the point itself. So I'm going to turn off the preview there. That's just a right click. And we're just going to look at just the cylinders that are visible within that radius. So I'll say list filter by bool mask filter. And of course, from the data type discussion, you'll remember that bool is short for Boolean. Just another version, name for that data type, just true or false. The list is the cylinders themselves. And the mask, we need to ask, is something within a certain radius? So we need some sort of radius. Let's say it's 30, I think that's what I said. And then is something within that radius, so not equals, but less than. So I'll just search for less than. And we want that distance, so I'll find that back here, geometry.distance 2. So if I look at this node, it says find the distance between the attractor point and the base of the cylinders. So whoever made this file was nice, told us that, is that less than this? And if it's true, see trues and falses, then that's our mask. Okay, something went wrong, right? We see all of them. Actually, it's just because you're visualizing everything that's in and everything that's out. So if you want to see just one, I'll undo the preview of that guy, and we can just look at, I'm just going to do a pass-through variable here, just the ones that are in. So these are just the ones that are within that, in that radius. And I can actually make this a smaller radius to make that maybe a little clearer. So then as that point moves around, we should only ever see the ones within that radius.
Can you do that with 2 points rather than 1 point?
Sure, you certainly could. You could have some logic based on the sum of these two things, for example. To your question before that I wanted to say, just wanted to answer that too, is can you select things by a pattern? And there are probably like multiple ways to do this, except I got lost. I'm gonna go over here. Okay. So let's make a series, and I'm gonna say A, B, C, D, E, and I kind of want to stop here. So I'm gonna do every. Oh, fine. I'll do a couple more. H. All right. So this should be 8 letters right here, and if I want to select every third one, then what I might do is something like is the is index of, so I can take this. Oh, sorry, not that way. Index. Thought there was a shortcut for this. There is a node. I forgot its name, so I'm not gonna hold on. I'll just make a. How many things are here? So list.count. So there are 8 things, and I'm gonna make a series from 1 to that number. So this is a corresponding 1 through 8, and I want every third thing. So I can say, is this divisible by 3? So is that a question? I wanted to use list. Yeah, there are multiple ways to do this. Yeah, so I can say. So I want to say if this number divided by 3 has no remainder. It's really convoluted. Does it have a remainder equal to 0? So here is the, this one. I want to do, this is what I wanted. If this guy modulo 3 is equal to 0, so this is the remainder, right? And if that's true, is that equal to 3? This is totally convoluted now, I apologize. Then, is this equal to 3? And then I have a true and false. Basically, that was just some rigmarole to get to, equal to 0. Yeah, you got it, right. So every third one. So this is every third value is now true. Then filter by bool mask based on this guy and this guy. And then if you look at the output, everything where it was in is in the first list, everything is out is in the second list. So you could also do something like every other in that case. There are probably better ways to do that, as Simon just pointed out. But that would be another way to use something like that. As long as you can shoehorn something into a list of trues and falses, then you can use list.filter by bool mask, which sponsored today's meeting. Along with ID8. Thank you, ID8.
I do have a question regarding.
Yep.
I tried the other day to use filter by Boolean mask using colors.
Yep.
And it didn't work. Do you think it's
You got just a list of colors?
like if I have 3 colors,
Yep.
I say select black, select black, and it yields an error.
All right, so we're gonna make a list of colors, and they're gonna have different values of red. So it's 0 to 255, and they're gonna have 10 of them. So like So this guy works by, you give it a bit value from 0 to 255 for each one of these things. So if I'm gonna give this red value here, this is gonna be, you can see that these are different colors with varying degrees of red. So that's the only thing. Everything else is no green, no blue, just different degrees of red. So if you wanted to do something like, you want to filter, the question you want to ask?
Filter out black. 0, 0, 0.
All right, so filter out this guy. And so it's going to be, so this is all, I'm going to print this is all I know, and I'm going to say the color.red value, so I can extract the red value, which is going to be the same thing as the input list, of course, but pretend I didn't know that, and say, is this thing equal to, well, let's say if it's greater than, we'll do, is it greater than black? Is it anything other than black? Is this thing greater than 0? And I should get, so this one is not greater than 0, so that one is black. So list filter, and we will find out, is this really a bug? Then our watch, I'll just do two different watches. This one is everything that has red in it, and this one does not have red in it. So it might work this time. It's possible you ran into a bug, certainly possible.
Yeah, I think you create a list of color reds there.
Yeah.
And for example, if you extract the first item, for example, and use the whole red green,
Yep.
instead of just the red, I think that's what I was having.
Okay. I mean, it's certainly possible. I run into weird things all the time, but it's also my job to run into weird things. But,
So is the chop list different than the you go back to the previous definition that you were working on?
this guy?
Yeah. Like you picked every third.
Yeah.
How does the chop differ from how you broke it up that way?
That's a great question. So that's another way to break this up. So you could do something like list.chop, which just will divide things into, you can either give this one length, in which case it'll repeat over and over again, like if I gave it 3, for example, then it'll chop it up into groups of 3 until it just runs out. I could also give this a series of things and get individual values. And then another thing.
So it's the first 3, whereas the other one was doing every third. Okay.
That's right.
Okay.
So, I mean, this is another way to do it. So you could actually just get this and get the last
one
item in each list. Now this thing is going to be the last item in the whole list, because remember, this guy, if I hover over this, will take anything. It's var bracket bracket dot dot bracket bracket, and take anything. So if I want to be more specific, I have to be more specific. This answer is GH, because the thing is taking the last thing of, is the whole thing, because it eats anything. So it's not going to go searching for a list, right? It eats anything. So that means I have to go down, it's going to take the last thing of this list. So if I want the last item of each list, I have to force it, do List.Map. In which case, this is another way of taking every third thing. Yeah.
If there are like a couple of listed lists, how do you get, for example, if there was like a third listed list,
Yeah.
how could you get into that?
In a pattern, or
No,
like
I
in
mean,
just one thing?
Now you're using just List.Map and it gets to the first listed list.
Yep.
If you had like another listed list into the second one.
Yeah. Okay. So we could do. We can make this slightly more complex.
Like going one more deep, like one step.
Like this guy.
Yeah.
I'm going to make this into pairs. So this is going to look weird. So this is now pairs of things. Okay, so here's the list now. So now it's even more. If you wanted to get the first item, so let's get this guy. This is the last item of the list. So if we did this, oops. Okay, so that wasn't complex enough, I guess, was it? So let's do one more. Set. You asked for it. Okay, so now I have something horribly complex. Now at this point, this last item, if you look at the input, it's var bracket bracket dot dot bracket bracket. It eats anything. So that means it will always work on the outside of the list. It won't go hunting for me. At this point, so this is if I just asked for the last item. So let's do one at a time. If I just asked for the last item, I do get something. The last item of the first level, which itself is a list. So I got this whole chunk is the last item of the list, right? If I wanted the last item of each of these lists, which will be the list CD and then the list GH, then what I could do is operate on that list, and then that's the function. So that's CD and GH. But if I wanted one more down, and I want the last item of these lists, these guys, so I want B, D, F, and H. If I wanted that, then I could map this whole thing. Let's map one more time. So basically you just count. I want to act on that list, and that's my function. So there you go, B, D, F, H. So that's the last one of each one. So the number of times you map is the number of times you skip down a level. I know that's. If you haven't seen the List.Map before, I really apologize that I just accosted you with that. But.
Is there a quick way that we can graph the whole thing, or we can flatten it? Just
Yeah, there's actually a node called flatten, and this is one way. So you can do, you can just do flatten overall, and this is a good example of a node that just takes, it eats anything, it'll just flatten the whole thing, so that you always get, you basically get the whole thing back. And then if you wanted to flatten in a particular way, say for example, if I wanted to, okay, so I'm gonna give you 3 examples of how to flatten this list. So say I just wanted to flatten the list outright. So there's A, B, C, D, E, F, G. If I wanted to flatten down one level, so I want to take these lists and flatten these lists, not the whole thing, then I could actually use flatten, and of course that's List.Map, right? Because I want to take it and move it to the right one. So that's taking each of these lists and flattening those, if I do it that way. Another way you could do it is if you want to flatten it from the right side in, then you could say flatten, if you use another node called list.flatten, then you can flatten a list by a certain amount. So you can say 1. And in this case, I'll flatten from the other side. So you can sort of mess with your data depending on what you want. Generally though, as a practice, you certainly can chain together list.maps or list.combines, but if you use the technique I was showing you earlier with just like encompassing, encapsulating something with like a custom node or even like a custom like a code block definition, they work the same way, then you can generally avoid that. If you're using chains of list.maps, there's probably a better way to do it. We certainly can. Cool. Thanks.
Awesome. If you guys will have any suggestion about what node you want to see next time, you can email me or say right now.
Or tweet.
Tweet. I know there's a lot of nodes there that we're always wondering, what is this used for?
Right.
So, any questions? All right. Well, thank you, Colin. This was really helpful. Great tips.
Thanks. Thanks, Edwin. See you.